Okay, so welcome back. We should have already set up, we should have already made some geometry, and you should also have already set up RhinoCAM, kind of generic settings there, which are the post processor and the stock. So once we have RhinoCAM loaded and all set up, what we need to do next is create a toolpath. So once again, if you want to refer to the Kapla software guidebook, pretty helpful on this topic. Go to kapla.arizona.edu and choose the software guidebook. Again, it's just loaded where I left off, but we should be on page 6 of the RhinoCAM setup tutorial. If you don't find yourself there, just go back to the top and go to Contents, under Modeling, select CNC Router, RhinoCAM, and scroll down till you're at page 6. Okay, and what we're going to do here is kind of follow along, although we're not going to do exactly the same thing that it says in this guidebook. Reason being that this set of operations is going to be what we would do for a kind of generic setup. In other words, if we were cutting something out of wood, which would mean we need a roughing pass, and if we were doing kind of the easiest finishing operation with parallel finish, we could follow along and set up our machining operation that way. But what I'm going to show you is a few different ways to do it. So there are some good pointers in here about what to look for and how to set up the toolpaths. But what I'm going to do is show you specifically a few different approaches here. This is the vertical, horizontal, radial, spiral. In this particular tutorial, I'm going to show you how to do a vertical contour. So once again, because we're cutting out of foam, and this is only true for foam, we don't actually need to do what's called a roughing pass. And a roughing pass is generally what you would do. So if you go in the machining browser under Program, under Machining Operations, click that drop down, and then expand the 3 axes. Those are all the types of toolpath that RhinoCAM will generate for you. And in general, if you were cutting out of wood, for example, you would always want to do a roughing pass. And what roughing will do is it will remove a lot of material fast. And then you can go in with a more detailed bit or with a tighter toolpath, kind of mill the surface in a precise way to really get the geometry look good. But again, because we're using foam, and foam is really soft, and we want to work quickly, we're going to go straight to the finishing. And so this video is the parallel finishing. So under this 3 axis, I'm going to click on parallel finishing. We should see this new window open. And I'm going to lead you through each one of these tabs and what settings to use in each one. So the first thing we want to do is set up what's called a control geometry. So a control geometry is just telling RhinoCAM where we want it to cut and where we don't. So in order to do that, I'm actually going to make a rectangle in Rhino. Clicking on the rectangle tool, and I'm going to outline the area of the geometry I want the Rhino to cut. And then if I go back to my parallel finishing, down here I'm going to choose Select Curve Edge Region. Then I'll select that rectangle I just made. And you should see like a little orange line appear there. And that's our control geometry. So that's the boundary of where RhinoCAM will cut. So once we have that set in here, and again you can remove it and reset it, these buttons down here, and we'll go to the next tab over. So under Tool, we want to choose a particular tool that we think will give us a good finish quality, but won't take too long to cut. There's a few bits of information to note here under tool, and again, these are the same tools we were loading initial setup video. These are all the kind of options we have to choose from in our shop. So first of all, we want to look they're numbered, so that's how we know which bit to choose when we actually go to set up set up the router. The next bit of information you'll see is it says flat mill or it says ball nose. And that just refers to the geometry of the bit. If you double click on one of these tools, you can see in this little diagram, so that a flat mill is exactly what it sounds like. It just has a kind of flat bottom. If we look at the ball mills, it has a kind of spherical bottom, which again is better for kind of curvilinear geometry. It's going to be able to get closer to the true surface with that type of end. So that's the geometry. The next bit of information is the size of the bit, the diameter. Excuse me. So you can see we range from 3/4 of an inch all the way down to about 1/8 of an inch. And the 1/8 of an inch is actually really slow. Most of the time we're going to avoid using that except for really detailed little finishing things. Again, in this case, because we're working fast and we're working with foam, we're going to choose something kind of in the middle. So I believe if we go down to number 15, or 16, we're going to use one of those bits in particular. Now, the last bit of information we need to find out is the length of the bit. See, it doesn't really say that in the name. We can also hover over here where it says comments. That will give you a sense of what materials you can use this bit on. So for example, some of the bits actually say foam only, which means you wouldn't want to use them on wood. But again, because foam is so soft, we can use pretty much any bit we choose. So we're going to choose one of these 3/8 inch ball mill bits. If I double click on number 15, again, it's going to show me the settings for that particular tool. What I'm looking for is this value down here, tool length. See, it's 2 inches. And if I go to number 16, you can see it's 3. So the length of the tool will matter for geometry deeper than what we're dealing with now. For example, if you had a piece of foam that was 4 inches, you'd probably want to choose the tool length that is 3 inches, right? So it would be more likely that you can reach all the deep parts of your geometry without causing any problem. Excuse me. So I'm going to go ahead and choose number 15, or I'm sorry, number 16, because that'll just be better for making sure we're not getting too close to the foam with our bit or tool. And then I'll go ahead and click OK. So you should see a little dash line outline where you should see it highlighted. That's how RhinoCAM knows we're using that bit. You can also just click off and click back on it if you're not sure. Make sure that that bit you want is highlighted. The next thing we're going to do is go over to feeds and speeds. So this set of options is determining how fast the router is going to move with that particular bit. Now you never need to change any of these numbers except for to load them for the particular bit that you chose. We chose number 16. Under feeds and speeds, we're just going to go to the bottom and click load from tool. You may see some numbers change or you may not. Basically that just is the right settings for that bit. So depending on the size of the bit, we want it to spin faster, we want it to cut faster, etc. We're going to go ahead and just use the settings that are already determined for that bit. The next tab over is clearance plane. In this case, we're not going to change anything. But basically what this does is it tells RhinoCAM how high to go in between like one cut and then. So again, we just want to make sure it's high enough that we're not going to accidentally cut through something when we're going from one toolpath to another, which again, in this case, isn't really a concern, but maybe with like weirder geometry it would be. And then we'll go to the next row of tabs here. First one is cut parameters. So under global parameters, pretty much leave all this stuff alone. Now the stock here number refers to how close it's cutting to the finished surface. See that in that little diagram, stock is telling it, here we're going to cut 1/8 of an inch away from the finished surface, which is what you would do if you were roughing, right? So you wouldn't want to cut all the way to the finished surface. And then with the finishing pass, we would come in and set that to 0, so that the finished pass is cutting the actual finished geometry. Under cut control here, we have a few different options, which just refers to like the order and the direction of the toolpath. We don't need to mess with any of it. What we do want to mess, or what we could mess with here, is the angle of the cut. If I hover over that input, you can see that'll just change the direction that it's putting those parallel lines. Now, if you think it makes sense for your geometry to just set it to 90 or something, you can go ahead and do that. However, I will warn you that anything other than 0 will actually make it take longer. The router tends to work faster in this dimension just because of the nature of the machine than in this dimension. So I would recommend you rotate your geometry rather than rotate in this case, just to save on time. And then down here, the last thing we want to look at is what's called the step-over control. So parallel finishing generates a bunch of parallel toolpaths that are just kind of, moving up and down across the face of your geometry. And for our case, because we're trying to work quickly, we're going to set that number to 40. And that, you can see that's percent of the tool diameter. You never want this number to be more than 50, because again, as the router is moving, it's only really cutting with 1/2. Good. Really. But basically, you want this number to be between about 15% and 50%. And the higher it is, the faster it'll go, obviously, because the less cutting it will do, but the less precise it will be as well. Okay, so we're going to set that number to 40. Then we'll go to Z containment. So in here, this is kind of useful. Again, I generally always specify a lowest Z. It is possible, even though we've modeled this thing pretty carefully, it is possible for geometry to have holes in it that you might not be able to see. So for example, we didn't have a bottom on our box, and there was a little gap in between this surface and the box surface. It's possible that even though we can't see it, RhinoCAM would find that gap and cut through, which would ruin not just our part, but it would also ruin the router cutting into the cable. So oftentimes what I do is I just specify lowest Z. In this case, we're going to set it to 0.5, because that's about as low as our geometry should go. And that means that no matter what, even if there are little holes or errors in our geometry, it's not going to cut into the bed of the router. And then the last few tabs here are entry and exit. So basically you can kind of tell what that means. When it starts cutting, what does it do? What are the speeds it moves at? And when it stops cutting. And then there's a couple other little more detailed things we can tell it to do. We're going to leave all that stuff alone. So when I'm done, I'm just going to hit generate down here at the bottom. You can see a little loading bar. And then we should have a parallel finish show up under our setup here. Now at the bottom, again, where all these visibility buttons are, if I go to the third from the left, where it says toolpath visibility, and toggle that on, we should actually be able to see the toolpath in our Rhino port. And so you can see it's taken a bunch of basically parallel lines, kind of draped them over our shape. So it's just going to move back and forth across our geometry and cut that. Now what we want to do next always is going to be to simulate the geometry, simulate the toolpath. So if I select my parallel finish, right click, and hit simulate here, you should see that it'll actually give us a little animation. And when it's done, we'll have a pretty good idea of what that surface is going to look like when it's milled. Not perfect, but pretty close. So again, we can see that because of the geometry of the bit, because of how far apart our toolpaths are, it's going to give us a certain kind of resolution to that surface. The other thing we want to look for here, and this is explained in the guidebook, is in the case of we chose a bit that's too short, it's going to show us anywhere where the tool is running into the geometry. So in this case, if you ran it with a really short bit, that means is that the router itself is going to ram itself into the stock, which is really bad. That can break the tool. It can obviously ruin your part. So again, we always want to simulate to make sure we're not running into the stock. The last thing to do here is going to be to check the file. Is what we're showing this part of the RhinoCAM setup tutorial. And so once you've done this setup, you'll see step 5 is to post and check. Now, there's a couple things to pay attention to here. The first I want to point out is that no file can be over 5 minutes runtime in RhinoCAM. What that means is you want to go in here under Parallel Finish or under Setup and right-click on that. Go to Information. And we should see in here, that's our Parallel Finish, that's our toolpath. And under Machine Time, we can see we're actually under about a minute, which is great. So as long as that number isn't more than 5, we're clear to move ahead. Excuse me. And then the next thing that I'm going to do is actually post it. So like I mentioned, if I save my Rhino file now, it will save the RhinoCAM setup, which is great. This is what we want to actually upload to D2L, is the Rhino file. But before we do that, to make sure our setup is actually correct, we're going to post it. And posting means we're going to make what's called a G-code file. That's the type of file that the router will actually need to run. In order to post it, I'm going to select Setup. So sometimes you'll find that it wants to rename it. So just go ahead and click on the icon there to select it. Make sure you have Setup selected, right-click, and then click the button Post. It'll ask you where you want to save. I'm just going to save it. Working file here. And it should copy the name of your file. I haven't given my file, so it isn't giving it a name, but we'll call this the loft. And then go ahead and hit post. You should see, again, you should see .tap, and you should see ShopSaber WinCNC UA. If you don't see that, go back to the first RhinoCAM setup video and make sure you get those settings right. Go ahead and click on the wrong. Nope. How does this work? There we go. Go ahead and post it there. Alright, and then what happens is automatically a Notepad file should open. This is actually the .tap file. And this is what's called G-code, and you can see it's a series of X, Y, and Z values. In other words, these are like locations. So the router is interpreting this code, and it's moving according to the movements that we've kind of written out in a sequence in this file. And there's two things we want to search for here that are outlined. And we're going to search for Z minus. So once again, the number one thing we want to watch out for is anywhere where the tool is going to run into the bed of the router. Again, because we zeroed the router, zeroed the file at the bottom, any number that's a negative Z value is going to be a place where we're running into the bed. So what I'm going to do is hit, it's F5, I don't know, or hit Control F on your keyboard to open up the search function. Also be really good to do. Go under Edit and go to Find. And so we're just going to type in the letter Z and then a minus, hit Find Next. And if we get this message, cannot find Z minus, that's great. That's exactly what we want. That means we have no negative Z values, which means that the router is not going to run into the bed. The other thing we want to watch out for, and this is more just checking the file to make sure that the setup is correct, is what's called we're going to search for M5. Once again, if we go to search, hit Control F, or go to Edit, Find, type in M5, hit Find Next. M5 you're going to see appear anytime you have a toolpath, or I'm sorry, a bit change. So anytime the router stops, you're going to change the bit, or in this case, when the file is done, we're going to find that there's an M5. So we should, if we scroll down a little bit, we should see that's the end of the file, which is correct. So then I would go ahead and close that. Then I would go back to my Rhino file, save as. Again, make sure you put the proper naming convention, R242, 22S, CNC workshop, and then put your name. That's going to help us just kind of keep track of everyone's files when we check them and run them. Go ahead and save that somewhere, and then that is the file you want to upload to D2L, the Rhino file itself. Otherwise, we will not be able to check whether or not your setup is correct. So I just want to reiterate, do not upload the .tap file, upload the Rhino file. Okay, so I think this concludes that segment of the CNC workshop. If you have any questions, ask your TA or find me. That's it. I'm signing off.